Let's get started. Yeah, so the first thing I want to talk about would be, why we have to use Python. I mean, this is an AI class. This is an AI program, right? And then you wonder why are we using Python for this? Why not Java? Why not JavaScript? Especially if you're coming from a web development background, right? And then it makes you it would make you wonder, right? That well, why do you have to settle for Python, right? What makes Python what it is? Why do we use it for machine learning, for data science, for artificial intelligence generally? And the first thing I'll say is that Python is a very versatile language. It's a very beginner-friendly language as well. In fact, Python has been around. Python is not a recent language. Python has been around since I think 1999. I'm not super sure. Yeah, I think I learned this in school, but I forgot it. Yeah. But then I know that Python spends more than 20 years in the system already. And the funny thing is this, Python wasn't a very popular language when it started out. People didn't really see any use for it, especially when you have juggernaut languages like Java, C++. Python didn't have any use, much use actually. And I would say Python started gaining more prominence around the 2014, 2015 period, right? And then I guess it coincided with the time data science and machine learning started gaining a widespread acceptance. Yeah. And it's also interesting in the sense that there's this probably the most popular machine learning course out there. Uh, Machine Learning by Professor Andrew Ng on Coursera. Yeah, so if you've taken the course before, then you you are aware that the programming language for the Python for the machine learning course was Octave and MATLAB. And it's funny, right? Because people don't use those languages for machine learning. I mean, these days. But and it makes you wonder because most of us didn't start our journey as at the time the course was active. And it makes us wonder, like, well, why do we have to use Octave or MATLAB if it's not generally acceptable now? I mean, yeah. But the thing was that as at that time, Python hasn't gained this general acceptance. It seems like now it hasn't become so ubiquitous with machine learning the way it is right now. As at then, it was just another one of the language. So yeah. So what makes Python what it is right now? I would say the first thing is probably what I put, what I inserted as the third point here is the and it's this point, the vast community and extensive library. Think of anything at all that you can do with a programming language. Python probably has a library or extension for it. It's crazy, yeah. But it's very useful. It has this very vast community. There are like thousands, hundreds of thousands of developers over the world, that make use of Python, that supports Python. And this vast community is not easily replaceable by new languages in the machine learning space. Think of Julia, think of Scala. Yeah, it's not so easily replicable. Yeah. And then another point is this: why did Python, edge out on maybe Java or C++, right? I mean, those are languages that might have been used for machine learning in the initial days of machine learning, especially in the engineering side of things. How did Python, or why did Python edge out, those particular languages? And the second point, the fact that it's easy to read and write. It's so easy to read and write with Python. It's almost like you're reading English. Yeah. And so simplicity is always going to trump, simplicity is always going to, to trump robustness, especially when robustness is not a very key criteria, in your particular use case. Yeah. And then when you look at languages like Octave or MATLAB, Python is just way more powerful than they are. It's extremely powerful. And another point about Python, I mean, what makes Python what it is today is that it's just so versatile, right? For example, I remember one of the projects I did in I think early 2020, right? So I had a data set I retrieved it from an API endpoint, using the request library in Python. Then I performed data analysis. All the analytics was done in Python, every single bit of the analytics. And then after that, I decided to build a model. I was still using Python. Then I decided to deploy it in an API endpoint using Flask. I was still using Python. Yeah. So Python is so versatile and it goes across multiple domains, across data science, across machine learning, across web development, automation. Yeah. So when people, reach out to me, they've not learned any programming language. I mean, they're just starting out in the programming career. I usually advise them to learn Python. Of course, it might give you a headache in the sense that you might not really know what domain to pursue initially, but it's uh, it's something that it's versatile enough that you can easily build on that knowledge for potential use cases in whatever domain that you're targeting. And also, it's an ideal choice for both beginners and experienced developers. So if you're just starting out with your Python journey, or you're already midway through your Python journey, believe me, Python is for you. Yeah. So moving on to installing Python and an IDE. Yeah. So an IDE is simply an environment that simplifies our coding, and it provides a friendly interface for Python development. So some of you might be familiar with VS Code. Yeah, I think VS Code is very popular. There are others as well. There's PyCharm, specifically designed for Python. There is Python, and there's Jupyter Notebook. Yeah, and for our use case, we'll be making use of Jupyter Notebook, right? I would say, and here's my reason. Machine learning or data science is a purely experimental process, right? You keep trying to repeat your process, you keep trying to repeat a lot of stuff until you get the result that you want. I mean, you keep trying to retrain your models, trying to get more data, trying to try out, I don't know, feature selection, and you get the optimal result that you're optimizing for. If you're using VS Code, this is not so easy. Yeah. And that's why we settle for Jupyter Notebook most times, because it provides this interactive environment for your training, for your Python on data science development, right? Yeah. So that's amazing. We use Jupyter Notebook. And you want to install Jupyter Notebook. I mean, if you don't have it on your laptop yet, then it makes sense for you to download it from Anaconda, right? Anaconda is just like a collection of useful tools for data science, and Jupyter Notebook is one of them. Also, another aspect of installing Anaconda is that you don't need to install most of these libraries that will make use of from scratch. Yeah, and then also you can make use of Google Colab. Right now, for this call, I'm making use of Google Colab, so feel free to do the same. Yeah, I mean, we live in a what's the name in the in a digital what's the name world where you don't really have to have like files on your local hardware. Yeah, so if you're very comfortable using Google Colab, yeah, feel free to do that. Especially if you're using a low end um device on a personal computer for your training, then it makes sense for you to make use of Colab so you don't hog most of your memory resources. You don't spend most of your memory resources, trying to work with an opponent. Okay, so having done that, then we can move on to introductory Python. Yeah. So one thing you need to be familiar with is this. The Python syntax is unique. Some of you might be familiar with it already, but when we talk about the Python syntax, it's the set of rules that define how the Python program should be written and interpreted, right? And then the syntax has to be consistent. It's always simple and it's designed to be highly readable, right? So we're going to talk about the naming conventions, we're going to talk about indentations, and we're going to talk about comments. But before we go into that, so for the novices here, let's try to run our first Python post, right? So yeah, so basically hello Python, right? And then I'm going to deconstruct this in a bit, but So basically what I did there, if you're not familiar with Jupyter Notebook before, so what I did here is this, I just use Shift and Enter, to run this code over here. Yeah, you can use Control Enter as well, but Shift and Enter on this code, and then it moves down to the next cell. So yeah, so yeah, so Shift plus Enter anytime you want to run your code, your Python code in Jupyter Notebook. Yeah. So over here we have the comments, which is basically describing what we want to do in this particular cell block. Yeah, and then we have this code print hello Python. Yeah, so print is the function we make use of. Don't bother, don't worry yourself too much if you're not familiar with some of my language right now. Yeah, so print is the function we make use of, and hello Python was what we wanted to print out. So what we basically told our compiler is this: print hello Python, and they did that. It printed hello Python for us. So isn't that amazing? Yeah, so Python is so simplistic, so readable. It's almost as if you're reading English language. Yeah. And then another example I want us to see is variables and arithmetic operations, right? Yeah. So you can use Pythons for your arithmetic operations. Now look at this. We have a variable over here, and the variable is storing 10. And we have another variable called y, and it's storing 5. Now, you might wonder, what do I mean by a variable? And here's the definition. Variable in the programming parlance simply means it's a container, simply put. It's a container that can store any value, so you can use it later. Yeah, so it's a container that can store values across different data types, and then you can basically reuse them later. So over here we have a variable called x, and then it's storing an integer called 10. And then we also have another variable known as y, and then it's storing an integer called 5. Then we can simply perform. Then we have a new variable called sum results. And then with sum results, then we're basically just adding up x and y, which means we're retrieving the values stored inside this variable. So here we're retrieving 10, and here we're retrieving 5. So we're basically doing a sum of 10 and 5. Yeah. So, and then we can print out the result. So basically print, as I said, and it's just a function. Don't bother yet if you don't know what the function is. And then, so we have a print, and print is basically, printing out the sum of x and y. Yeah, great. So we have 15. So there are certain things you have to be familiar with concerning the naming conventions. So if this is your first time hearing naming conventions, naming conventions are basically, the rules that govern the name of identifiers and programming languages. So, and by identifiers, we're referring to variables, we're referring to classes, to functions, and then here's something that you must know. Here are the list of conventions that are very important for you to know. So I mean, those identifiers, they must have with either uppercase or lowercase letters. Yeah, it's very important that, we do this. You cannot start an identifier you cannot start an identifier with an integer. It's always going to start with a letter or an underscore, right? And then you cannot use special characters like exclamation mark, like ampersand and likes. You cannot use them within an identifier. So your identifier can contain digits, or your identifier can contain digits, even though they cannot start with digits, right? And then Python is a case-sensitive case, right? So results here and then results here, they are not the same thing, right? Yeah. So, and then you cannot use your keywords as identifiers. So over here, I have a first name called Stephen. You can see first underscore name. And then I also have another first underscore name over here. So basically I want to print this out, right? So I'm having an errors which says the first name is not defined. And it's actually simple in the sense that the error is due to the fact that I capitalized the starting F here, but I didn't do the same over here. Yeah. So they are not the same thing, even though they might read like the same thing, they are not the same thing. So Always keep that in mind, right? Yeah. Okay. Moving on. Indentation also is very important. Yeah. It's very, very important that, our indentation on point, right? So, because indentation is what we use to identify code block. For example, we have a conditional statement. Don't bother yet if you don't know what a conditional statement is. But we have a conditional statement, and then it's indented. So we're basically saying that if 2 plus 2 is equals to 4, then we indent it over here. The spaces right before the print, the print statement is what we meant by indentation. So we're like, if 2 plus 2 is equals to 4, then print and grade at max, and it does that perfectly. Yeah. But look at here, we didn't indent this particular print statement. Yeah, and then because of that, it's brought up this error, called an indentation error, expected an indentation block. Okay, so most languages usually use the indentation for easy readability, but Python syntax compiler is heavily dependent on um, on on how you do your indentation. So always keep that in mind. Okay, so moving on, another stuff I want to mention before we get into the nitty-gritty is comments. Yeah. So in terms of in terms of comments, there are different kind of comments, and there are two comments I would like us to look at today. So the first one is single line comments, and this is pretty straightforward. We probably have seen examples of these in my earlier examples. So we have two comments, and one of them is a single line comment. Basically, all you have to do is just to put the hash sign. Yeah, I think it has another name, but yeah, we just call it hash anyways. Yeah, so we have the hash sign, which means that this is a single line comment, right? So, which means that if you want to extend it for the multi-line, you have to do something like this. Uh, yeah, and then you have to do something like this. So that might be a bit stressful. So you can simply just use multi-line comments when you want it to extend that first line, right? So if you put something, you can have like three quotes with three quotes after, and then you write your comments inside. Okay, so moving on to data types. Yeah, so data types are straightforward. We're already familiar with this in every aspect of our lives. For example, we have animals in different categories. I mean, different species. Yeah, it goes the same for programming languages. We have different kind of data types. Every value we mixes of every data we mixes of, in the programming language is classified into a certain type. All these types, they all perform their individual purposes, their unique purposes. Yeah. So integers, we're all familiar with integers, is basically whole numbers. And then we have floats or floating point numbers. Those are numbers with decimals, right? Yeah. We always have a decimal as a point. And then we also have strings. We already made use of strings. Strings are like characters enclosed in a single or double quotes, like hello Python or AI Saturdays, right? And then we have Booleans as well. And these are basically, represented to a false statement. We mostly use those for logical operations. There will be more on that later. So for integers, we have my age is it's basically you have a variable and then you can store an integer inside it. For floats, you have a floating point number, and then you can easily store a decimal a number with a decimal point in it. We also have strings. Strings means that it's enclosed inside a quote. Yeah, and then we also have booleans, and booleans are simply true or false statements. So we can say it's true. We can say it's student, and then the student is a variable storing a boolean value called true. Yeah. Okay. So one thing I would want us to do, I mean, right before we move on is this. Uh, so what is the big difference between 17 and then 17 and then so in terms of data type, look at these three examples and let me know in the chat the big differences, between all these all the three examples over here, right? So we have three different kind of 17s, and I'm wondering, what the big differences between all these 17s are. Yeah, so let's use about 30 minutes, 30 seconds, to type that out in the chat. Mm. Oh, okay. Oh, great, great. Okay. Okay. Wow. Okay. Oh, okay. I guess I would have to take up. I would have to take up the what's the name? The level of these explanations. Yeah. Looks like we have lots of bright people in here. Okay. 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 Great. So yeah, I'm glad you're following. It might just be a case of we having lots of people who are already at an advanced level. Yeah. Okay. Yeah. So that's really great. So basically, uh, in this example, we have 17. All the value is 17, but then this is a whole number, right? So this is an integer, and then we have another 17, but this is exposed inside a quote, so it's a string, right? And then we have another 17, but it has a decimal point, even though this value is the same as this value, right? Yeah. But the data types are different. And also they are using different number of bits in the back end of the programming language. I don't want to go to technical because I'm a computer science student, so so I have that potential, but I'll try not to do that. Okay, so I think integer is just 4 bits, while floating point numbers take up 16 bits in storage. Yeah, so you should always remember that. So in instances where you can use an integer, but you're using a float, you should know at the back of your head that you are you are wasting resources. Yeah, so the resources are so negligible, so we don't have to pay much attention to those. But in the long run, you're actually wasting resources. And then when you're working with, I don't know, billions of points of data, then all those small resources they are wasting, they count, right? Yeah. Okay. So moving on to functions. So functions are basically reusable blocks of code that perform specific tasks. So, for example, I mentioned that print earlier on is a function, and you might wonder what makes print a function. Print is a function because it makes us reuse a block of code repeatedly over and over again. So print represents the function, and we can simply call print every single time, every single time we want to um, perform that specific task. And you may wonder, what's the big goal for this? Why do we have to do this? Right. And then I'm saying it's important for organizing code. Yeah, you'd always see the difference in a code base where they are making use of functions, the ones where they are making use of sequential programming, Yeah, so there's always going to be a difference, right? It's just look more organized when you're using functions. And also it promotes code reusability. You don't want to be defining a particular block of code repeatedly. You don't want to do that when you can just when you can just define a function once and then we use it every single time you need that piece of code. Yeah, so this is very useful. You're going to realize this later on. Yeah. So I have an analogy here, right? So so imagine that you have a set of instructions to bake a cake, and instead of you to repeat those instructions every time you want to bake a cake, you can just write them down in a recipe book. So when we're talking about functions, we're basically talking about recipe books for code. Yeah, so we can always define our blocks of code and we can always release them. Yeah. So I want to show us some particular what's the name? Some particular information about functions. Yeah. So every time you're using a function, be it has to be defined using the def keyword. remember I mentioned that Python is so close to English language. Yeah. So you use def to define your function. Then you follow it with your function name, your parentheses, and a colon. More on this later. Yeah. And inside the function, then we can write the code that should be executed when the function is called. Right. Yeah. So here's an example of a simple function. Yeah. So basically, I already explained what a comment means. So when you say comment, you know that it's describing a particular code over here. And I also mentioned what a multi-line comment is, using docstring, using three codes, exposing your comment with three codes. It's basically a docstring. Yeah. Okay. So right now we have a function, and it has this function. It has this def keyword, which means we're trying to define a function. Then we have the function name, and then we have the parentheses. Inside the parentheses, we have an argument. More on this later. So you can simply provide an argument, and then you can simply provide an argument, and then it prints out that particular argument. So I'm trying to say, anytime the greet function is called, you have to print out hello name. So the name has to be provided. Now look at this. We have greet allies, and then it says hello allies, and then we have greet jacks, and it says hello jacks. Right. So look at here, we have greet Steven, and then it brought up an error. Looks like what's the name? Looks like my name might not be in the same format as this. So we have an error. Name Steven is not defined, and I'm wondering what went wrong. Just so to know if anyone of you is following, can you maybe type out in the chat and tell us what went on with this particular instance? I mean, I basically I was trying to greet people, based on their names. So names are provided, and then we function greet them, basically saying hello name, right? So we have Alice, and then the function outputs hello Alice. Then we have Ajax as well, and then the function also outputs hello Ajax. Now I'm trying to greet Steven, which is me, yeah, but the function refuses to to greet me for public. I'm sort of wondering what's went on. So can anybody explain in the chat? Okay, it's not in quotation, it's not string. Steven is not a string, not string format. Oh, okay. So I just have to make Steven a string. Okay, yeah. So let's try that out. With Steven, but now in quotes. Okay, looks like that works. So okay, thank you everyone. Yeah, that's on point. Yeah. So Steven was a string, and because of that, we had that particular error. Okay, so another thing you should know is that function can take inputs known as arguments to perform different tasks. Arguments are specified within the parentheses when defining a function. Right? Yeah. So this is an argument, right? This is an argument, and then this is an argument. So greet is defined. This greet function is defined to receive an argument. So what happens when we don't put an argument inside greet? Yeah. So let me do that again. Okay, so what happens when we don't insert an argument? Oh yes, so greet is missing one required position argument. So greet is designed to receive an argument every single time. So let us keep that in mind. Okay, so here's another example of a function with arguments and returning a value. So basically over here we have a function called add numbers, which is very basic. It's just like you want to add two numbers together. So the function is always going to expect A and B, and basically you return the sum of A and B, right? Yeah. So calling the function, we have to provide the arguments 3 and 5, and then the result is going to be 8. It's just going to add up those numbers for us, and then it's return that for us. Okay, in the cup of introduction to functions, so we have the keyword known as def, which is what we used to define. we have the function name, which is what we'll be calling in further utilization of the function. And then we have the parameters of the function, x and y, which we always have to provide arguments for, right? So colon, you always don't forget this. You always need a colon at the end of your function name, and then yes, the function body. Now every single thing under the function body is indented by a tab, right? So it's always indented. And then the function body contains a doc string, which is a comment. It contains the code, which is x plus y, and then we have a return statement, which is what we're trying to return. So basically, in the function body, we are adding the two parameters together, and then we are returning the result of the parameter. So the result is basically a variable called z, and then we're returning z using the return keyword, right? Okay, great. We're making progress. So let's look at here. In some instances, you're going to have what's the name? You're going to have functions with default arguments. Yeah, don't forget that. You're going to have functions with default arguments. And how do we do that? Basically, we can just provide a default value. Now look at the function over here. It's called calculate area. So it's a function which we initialize using the def keyword, and then we have the function name, and then we have the parameters. Now, how do we provide default arguments? We basically just set it to that value over here. So over here we have length is equals to 1, and then width is equals to 1. Your default argument can be anything, right? Yeah. So yeah, and you might wonder in what kind of application is this default argument? Is it useful? And I'm going to give you an example. Imagine you're trying to open a bank account, right? Yeah, so you're trying to open a bank account with a bank, and then at the time you're opening that bank account, your default net worth within that bank account is going to be zero. Zero whatever currency you're using, zero Nigerian naira, zero US dollars, zeros CFA. Yeah, so it's always going to be zero. So that's a very good instance, when a default argument is going to be needed, right? And of course, the fact that we provided a default argument means that we can make use of that function without explicitly providing value for width and length. Yeah, so we have a function called calculate area, which we were trying to use to calculate the area of a rectangle, right? So now I want you to take a second, maybe 20 or 30 seconds, to think about how this solution is going to be structured. So right now I haven't written anything. So basically I just have a function, an empty function. But so that this code won't provide an error, I wrote pass. So basically this was what I did. I defined the function name, I defined the function argument, and then I wrote pass. Right. So this is not going to bring up an error. The function is an empty function. And you might wonder, why would you need to pass? Let's say you're trying to build an application, and then you want to, you know the kind of functions you're going to make. Let's go back to the bank example. So you want to have a function for money withdrawal. You want to have a function for deposits. You want to have a function for changing the PIN. So in the initialization of your entire code-based development, you can define all these functions, and then you can write pass, right? So that you can go back to them later and update them. So initially, you don't need to make use of them, but you can just define them and then write pass, which means that this is an empty function and you want to go to it later. Okay, so I wanted to take as I mentioned earlier, Python is an intuitive language, which means that everything should come, by intuition. So basically over here, we're trying to define a function that calculate the area of the rectangle. What should come to your mind is, how do I do this? Right? Yeah, you don't have to type your thoughts out, but just think about it. I mean, just think about it for maybe 10 seconds. So if you're going to do this, how are you going to do it? How are you going to define how are you going to write this function? What will be your expected results, right? All right. So over here, my own intuition says that basically we're trying to calculate the area of a rectangle, and we already know. I think every one of us did it in our nursery school. But to calculate the area of a rectangle, you just have to multiply the length by the width, right? Yeah. So which means that we're going to take the two arguments, the two parameters, and we're going to multiply them together, and that will be our area. So over here, I'm going to delete pass, and I'm going to say area is equals to length times times width. Yeah, and then I can return width. I can return area. Yeah, so usually we have to multiply. So yeah, so this is what you do. You just multiply, the two values together. And notice something I did here. I wrote x instead of times, right? And don't ever make that mistake. Don't make that mistake. Yeah. So be always worry of that. So mathematical operations, multiplication uses this. Yeah. So if you're familiar with writing x in your notebook, yeah, you shouldn't make that same mistake when you're trying to do this. Yeah. So basically, this is our function. So and what I did is I'm taking I'm taking the parameters length and the width, and I'm multiplying them together to get the area. Then I'm returning the area. I hope that's clear. Yeah, so right now I'm running the function, and now I am trying to calculate. Yeah, so I'm trying to calculate the area. So I provided a length of 3 and a width of 6, and I have 18. One other stuff I would say is this. Look at this instance, this particular instance. I have what's the name? I have the area, and then it's 3 and 4. I don't have to specify the length and I don't have to specify the width every single time. I don't have to specify the argument. I can just provide the values for those arguments, and we are good to go. Okay, so let's run this, and then unexpected, the answer is 12. Okay, yeah, so also we can also calculate the area, right, without providing any value, because we already set a default value, and the default value is 1, right? Yeah, so we have length is 1, and weight is 1, and then we can just multiply both together. Now look at this instance. I'll provide the two values, 2 and then 4. But over here, I have an error, right? And I'm wondering why I have that error. And I'm not so sure what I did. We're basically trying to calculate the area of a rectangle, which is basically the length and the breadth of the rectangle, right? Yeah, so I'm wondering what I'm doing on, and yeah, so looks like the error is due to the breadth what's the breadth value that I provided. Yeah, so we are making use of the breadth. Yeah, so actually the breadth, the width, they mean the same thing, but your your Python programmer is a robot, right? You have to tell it that this thing means the same thing. Yeah. So when you don't specify that, it's not going to read your mind and automatically convert width to breadth to you. So yeah, we should always be wary of that. So if I want to make this right, what I have to do is this. What I have to do is this. I'll basically change this to okay. Yeah, so and we have our results. Okay, yeah, so also we can calculate I'm also trying to calculate area, and then I have another code over here. Yeah. And then I have this error, and I'm wondering why I have this particular error. So can anybody explain why I have this particular error over here? One thing I can see is that the error here is quite different from the error over here. So maybe somebody can explain why you have that error. So we only defined it's expected less than 3 arguments, because we only defined 2 arguments, and we are providing 3 arguments. Yeah. So don't ask your what's the name, don't ask your mode, don't ask your what's the name, your functions what you didn't provide or what you didn't design them to handle, right? So in this particular instance, I have more parameters, more arguments than I specified in the parameters. Yeah, so the way to make this right would probably be deleting one of these values. Yeah. Okay, great. So before we move on to the next example, yeah, I was told that Chinelo has an argument about options. Yeah. So should we take that now? Okay, because definition. Okay. The very first one. Okay. Looks like. Oh, sorry, I didn't explain that. I think I would explain it somewhere down there. But when you print out what's the name, when you print out when we print out values, I mean, when you want to print out values, you have to find a way to deal with the variables, right? So you can easily do something like this. Print, print, um, print hello, and then you need to find a way to print the variable, right? So usually what we use is string concatenation. And string concatenation simply means concatenating the returning stuff together. So when we're talking about string concatenation, you have you are using plus. It's the same way you have it's the same way you have what's the name? The same way you have mathematical operations, you have string operations as well. So we can do something like this. Print name. So we have to say the name very understand. So we can have a name, and name is Steven. Sorry, but I like my name a lot. Yeah. So so we can have a name, and then okay, so we can do something like this. Hello, Steven. So now let's say we have a lot more variables. We have age, we have a city, we have school, we have school, we have gender, we have uh, we have nationality, and we have address. Now this is so long, and then and this is so long, and since this is so long, it's going to be a bit difficult for us to keep I mean integrate uh, all these variables in a single sentence. I mean, maybe you want to say a boycott stadium is a male guy called Steven is lives in a particular city. His age so he lives in the particular city, and then he has this country nationality, and then his address is this. Now this is a very long sentence, and it's going to be pretty hard for us to have it in a single sentence using a string concatenation. So we are going to have plus name, plus we're going to have something like this: a boy named Steven, and plus lives in what's the name? Lives in a city called. Then you have city as well, and then you have what's the name? You have and the the attend what's the name? The attend so school. You are going to add another plus. Now this is a very stressful. This is a very stressful way of doing this. This is a very stressful way. So instead, you can just make use of f string. So f string is just a string formatting kind of style, and then we can simply just say print, and then you have f before the quote, before the double quotes, and then you can simply say hello, and then you insert the variable name. Yeah, so this is you insert the variable in a what's the name in a curly brackets. Yeah. So this is how it works. It's quite simple. It's just the way to make sure that your formatting is nicer. Yeah. So what we have over here, I can simply replicate it down, and I can say something like this: a boy name, lives in a city called city, and he attends. Now look at this. This is cleaner. It's so readable, and it makes a lot of sense. Uh, Let me know if that makes a lot of sense to you. Okay, perfect. Yeah, perfect. Thank you. Okay, so we can move forward. So if any of you have a question, please feel free to drop it in the chat, or you can just ask at the end of the talk. Okay, so moving on. Moving on. So we have another example of function over here, and then so and this in this particular instance, you know, we have what's the name? We have a keyword. We have a keyword. We're trying to provide keyword arguments over here. One we made use of was default argument. Yeah. So looking at the keyword argument, we want to create a function called print info, and then I think the following argument: name, agent, and city. Agent city. So we can have something like a a this was supposed to be a 5 years old individual named Lama lives in Santa Cruz, right? Yeah. So, in case you're familiar with machine learning, then you might have heard of Llama. I've been playing around with it these days, so it's quite interesting. Okay, so this is the sample output. So, and what are our keywords? We have a 5, we have a Llama, which is the age. No, we have a 5, which is the age. We have the name, which is Llama, and then we have the city, which is Santa Cruz, right? So it's very important that we we are able to spot what we need immediately. We're looking at what's the name? We're looking at a particular problem. Yeah. So we have this function, and then we have to define several keywords arguments, right? So right now I didn't pass in any parameters, but based on this question, based on what you create here, what do you think our argument should be? I haven't defined any parameters yet, but what do you think should be our parameters over here? Okay, so we just have to pass the name, the age, and then we have the city, and then we can now have. Remember, we use string just now, so we could have something like info, and then we could have something like this. String, don't forget your string, and then we could have a, and then age, yes, code, individual, name, lives in city. Great, and we're good to go. Okay, so yeah, so that's our function. So I'm passing in my info here. So I'm Steven. My desired age to be 18. Yeah, and then I used to live in Abeokuta, right? And then I can run this. And oh, now this is not printing out. And does anybody realize why this is not printing anything? Oh, yeah, thank you. So I'm not having a return statement, right? I'm not having a return statement, so I have to return info. And then once I do that, then we have this. Yeah, beautiful. Yeah, so we have an 18 or 18. So you need to be specific of this as well. You know, you have to take into consideration the kind of what's the name? The kind of value you're getting, right? So you can do something like use a conditional statement, if and early, and you know the kind of what's the name? What to use here. Maybe we're using an A or hand. Yeah. Okay, so we have a promise who is a favorite friend of mine, and then she's 17. She lives at the bottom, and then yeah. So okay, so we have a 17-year-old individual named Promise living in the garden. Okay, so I have this, and I'm wondering why. Why do I have all these errors? Right? Yeah. Does anybody understand why I have all these errors? Okay, so we finally have some answers. Yeah. So we didn't provide any default argument. I mean, we're supposed to. I mean, we're working with keyword arguments. We don't have default argument. Yeah, so I can't just do this. I can't just do as I wish. So I have to provide values, to think out stuff. Yeah. Okay, so look at this. We have an example of a function. of a function with multiple return values, right? Yeah. So we're trying to create a function for get circle info, right? And then that takes the radius of the circle as an argument and return both the circumference and area. So note that pi is equals to 3.146. So if we're going to do this, what value, what parameter are we declaring over here? Yeah, thank you. Thank you, Sarah. You are so right. Yeah, so we're providing radius. And then after providing radius, then we can simply calculate circumference. I'll just call it circum. And then we can calculate area as well. So in case the mathematics is rusty, I'm here for you. So circumference is 2 pi r, so 2 times pi, and then times times radius. Now I didn't define my pi, so I have to come here and define my pi. My pi is 3.142. If you want, you can put your pi here as well. Pi is equals to 3.142. But if I'm providing my pi here, it's redundant because pi is never going to change. It's always a constant value. So why am I providing it here? So always be aware of your engineering decisions. Make sure that you're making the right choices in your in your design. Yeah. So we have pi over here, and then so we can simply have circumstances our circumference as 2 times pi times radius. And also we have the area, and area is just pi r squared. So we have pi r squared simply means r times r. So we have radius times radius. So how do we return multiple values? So we can just do something like this: return circum, and return, and then area. If you want, you can put this in bracket, but it's not needed. So you can put it in bracket, but it's not really. Now, okay, if I run this and I run this, oh, yay! So we have a nice result. All right, thank you very much. So moving on, this is a very tricky one. I shouldn't have provided an int, so I'm just going to remove the int. Yeah, so how about a function with a variable number of arguments? We want a function that can take a crazy amount of arguments. Does anybody know how we're going to do this? You want a sum, or you have a function called find sum, and you want this function to take a huge number of arguments. I mean, you might not have it could be 1, it could be 2, it could be 3, it could be 4. You might not provide it. You want it to provide it. How do you do this? Looks like that's a tough one for most of us. Okay, I guess I'll just help out. So here's the int. Here's the int, So the int is basically you have to use args, right? You have to use star args. And then you might wonder where you should use this. And yeah, so you can have star args over here. And then let me delete this. You can simply just sum up the entire value, right? So sum, and oh, Peter only did it. Okay, yeah. So you can basically just sum up all the value of x. Yeah. So yeah, so we can have this. Oh, I didn't state risk return. So yeah, you always be careful about what you're doing. So we can have something like find sum, and then we can provide 1, 2, 3, 4, 5. Let's see. Yay, it works. So we can also have find sum, and then we can have 1 and 2 and 3. Okay, let's see. Yay, so yeah, that's really lovely. Okay, so that's all about functions. I have some additional exercises for you here. I really wish you can do them on this call, but we don't have the boundaries for that. So you want to go through all of these on your own. You have to write a function that checks if the given number is prime and return true. How do you know if the number is prime? Use your intuition for every exercises, for every line of code you want to use, you want to write. Always try to use your intuition first, So if you want to find out the prime number, how do you do that? Then you have to decide if that number is divisible by what's the name? By any other number, right? Yeah. If that number is divisible by any other number aside from that number itself and one, then that's not a prime number. So you need to like think intuitively and then figure out how you want to extend that programmatically. It's very, very important. Yeah. So always try to think before you write code. Yeah. Lots of people don't do that. Yeah. So it should be special. Okay. So you can also create a function. Another exercise is to create a function that takes a list of integers and return a new list with only the even numbers from the original list. We haven't talked about list, but yeah, how would you do this, right? How would you look to a list of numbers and then return a new list with only the even numbers? You need to find out how to decide even number. If a number is not divisible by is divisible by two, then it's an even number. How do you represent this programmatically? So I want you to figure that out. So you can, the last one is to implement a function that calculates the factorial of a given positive integer using recursion. Now this is tougher. And then I'm not going to say anything, but just think about how factorial are represented and then, trying to do something. Try to create something. Try to think about it intuitively and then, try to figure out how to write it programmatically. All right, so that's it about function. One final thing you should know about function. You can use the Python built-in help function. One thing you should have noticed is that all the functions that we've been listing, they are the ones we've been working with, they are custom functions. But then we have built-in or inbuilt functions like print. This is a custom function that we designed ourselves. But this is a custom function, right? So you need to pay attention to, what is custom and what is not custom, right? So if you need to find help, you need to find out more information about that particular function, then you can basically just use this inbuilt function called help and then pass in the function itself. So look at this. I have function to greet the person by their name. It's basically just getting out the doc string that I defined in that code earlier. And then let's look at print. Okay, so look at print. So over here we have our print, which is a built-in function, and then we have it's listing out the values to respect, the way it should end. /end means that new line. We might not want to let it go to a new line. We might want to end with a tab or something. So it's always very important that you use help to define or to understand a particular function you're using better. It's always the same feeling as checking the documentation of that website and seeing how stuff is done. Okay, so that is all about function. And then I think we're like halfway already. Function is like the big part of most of what we're going to do here, right? Because we'll be needing them a lot moving forward. So moving on to Boolean data type. So the Boolean data type represents two values only. We have true and we have false. So here's an analogy. Imagine you have a magical switch that can only have two states, on and off. It's just the way you have an electrical switch in your houses, right? Yeah, it's just on and off. And then the Boolean data type works similarly. It's just two values, true and false. And the Booleans are fundamentals for making decisions in your program. You might wonder what is useful for, what would I need true for, what would I need false for? But Booleans are like very integral to the way we use conditional statement and loop to control the flow of the program. So you're going to see in a bit. Okay, so here's an example. Is it raining? It's raining. It's true. It's raining is the variable, and then you just set it to true. And then we have it's sunny, and then we're setting it to false, right? Yeah. Also, we have if, elif, and else statement. These are conditional statements. So the if statement is used to execute a block of code if the condition is true. Elif, which is the same as else if, that after considering if, what if is not what if is not applicable, then let's consider this, right? So we have elif. So elif is just allowing you to check multiple conditions sequentially. Now else is like when none of the previous conditions are true, then you provide a fallback option, right? So we can have s is equals to 10. Now if x is greater than 5, now this condition, if this particular condition is true, x is greater than 5, then we have this printed out, right? X is greater than 5. But early, which means that we're looking at another condition. If x is equals to 5, then we can have x is equals to 5. Now, else, which means that if the previous conditions here are not true, then s is less than 5, right? So we've set x is equals to 10, which means that the function or our compiler is going to check if x is greater than 5. Now, in this particular instance, s is greater than 5, then it's going to print out this, and it won't bother checking out the rest of the conditional statement. It's not bother going to check out this. Once this has been satisfied, once the if statement is satisfied, it's not going to bother, checking through the rest of the code. So we can play this out, and then yeah, it's only stopping here. It's not bothering, moving on to others. Okay, so moving on, look at logical operators. So moving on to logical operators, you can have logical operators are just a way to combine Boolean expressions. You probably have heard of them before. Yeah, and or not. So the and returns true if both statements are true, or returns true if at least one condition is true, right? And then the not operation negates the result of the Boolean expression. So if the number is 10, and then if the number is greater than 0, and the number is less than 100, so the number needs to be between 0 and 100. It needs to be somewhere in between. So print the number is between 0 and 100. Now, if the number is less than 0, or the number is greater than 100, then you can say something like this: the number is either negative or greater. It doesn't have to satisfy both conditions. It only has to satisfy just one of them, and we are good to go. Okay, so moving on, if not number equals to 5, which means that you don't want the number to be equals to 5, so you precede it with a negation by specifying not here. And then if that number satisfy this particular expression, then it's going to print out it's going to print out this code block. Yeah. Okay, so running this, let's see what happens. And then this condition is not satisfied. No, this condition is satisfied. The number is greater than 0 and the number is less than 100. This is not satisfied. The number is not less than 0 and the number is not greater than 100. But this also is satisfied, right? Number is equals to 5, not yeah. So it's more like you don't want the number to be equals to 5, and the number is not equals to 5, so it prints out the succeeding line of code. Okay, so that's it about logical operators. We are going to make use of it a lot today. Yeah. So moving on, we have list, and then if this is the first time of working with a list, then you know that list other collections of if this is not the first time, you know that they're like collections of elements in Python. Yeah, but if this is not your first time, then if this is your first time, then I would say that list is just like a list of something. Yeah, let's say you want to go to the market and you need to get a couple of stock over there, then you're working with the list, right? Yeah, and then when we create list, we make use of a square bracket and we separate the elements inside the list, using commas. So we have apple, we have banana, we have orange. All these are elements inside a list called fruits. Yeah, and then we can now access those elements via indexing, right? So you could have something like this, print 0. You might wonder, well, what is print 0, right? I mean, the numbers, there's no 0 here. We have a 1, we have a 2, we have a 3. Yeah, you might wonder, right? But you should understand that computer always has something from 0. So the index on this particular value is going to be 0. The next one is going to be 1, and then the third one is going to be 2. So if we print out all these, then we are going to the corresponding value or element of the index. One other stuff you need to keep track of is list operations, right? Yeah. So, and you might wonder, what do you need the operations for? Let's look at slicing and concatenation. So slicing is just a way for you to extract a portion of the list. Let me give you an example. Let's say you're working with numbers, right? Or let's say you're working with a data set, and then in the data set you have what's the name? You have like a list of rows of data, maybe millions of data, and then you're working on your local machine. So you can work with millions of data. Maybe your machine can only handle 1,000. So that means you can make use of this slicing in that aspect. So you can just slice off a portion of the entire list and work with a particular value. So that's a reward example. So in this case, we have numbers, which is 1 to 5, and then we can slice from 1 to 4, right? So keep in mind that the index starts from 0, so which is it's going to start from 2, 3, and 4, right? Yeah, so it's going to be the index of 2 will be 0, the index of 2 will be 1, and then the index of 4 is going to be 3. So another stuff to take note is that it's not taken in the last value. It's starting from the first value and stopping right before the last value. So even though 5 is the index of, even though five's index is 4, yeah, it's not going to print out 4, it's going to stop right before 4, right? So it prints out all the numbers starting from start to stop, without printing out the stop value itself. I hope that is clear now. Okay. Another stuff is this, you can, concatenate list as well. Remember that we are familiar with integers concatenation, which is addition. We're familiar with string concatenation, which is basically adding several string values together. We can do the same for a list. We can simply add more numbers, with the numbers that we have here. And then you can combine both of them together using the addition sign. And you're going to have a new list. Yeah, so that's great. Also, moving on to list methods. So another thing you need to be familiar with is that list have various built-in methods to modify and to deal with your elements basically. So you can append to a list. You can append to a list when you want to add maybe more than what's the name? Let's say you want to add 2 or 3 names, to what's the name, to a particular list. Instead of using dot append every single time, you could use dot extend. And when you use dot extend, it's basically adding you can provide a list and then just append the entire list to the list. So it's more efficient in the sense that instead of calling the append function multiple times, you can simply just use the extend function once and add multiple elements to the list at a single file. Yeah. Okay. So, and also if you want to remove from a list, you can just use the remove method, and then you specify the value you want to remove. Then it removes it straight up. Yeah. Okay. Now pointing what's the name? Pointing out our value. We have Alex, Charlie, David, Eve, and Frank. So I clicked on append twice, and then I also removed Bob, so we don't have the Bob anymore here. Okay, that's great. So we are making progress. So the next step we need to talk about is for loops. So for for loops, it's quite straightforward. It's just trying to iterate over an element in a particular sequence, right? So you have like a list of numbers, a list of anything, and then you can iterate through them, pick every single one of them one by one. It's like you being in a list of rooms. Maybe you're at the party, like the wedding party going on in my hotel right now. Yeah, so like the wedding party going on in my hotel right now, So let's say I go downstairs and then I want to greet every single person at the party, right? Yeah. So all I have to do is just, iterate. I'll use a for loop. So for everybody at the party, and then I walk up to every single one of them and I shake their hand. Yeah. So that's the for loop. So basically you have a list and then you can iterate through that list. You iterate simply means you 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 interact with every single uh, element in that particular list, and then you can do whatever you like with that particular list, right? So most of us that are Nigerians, and then you you've been in a classroom. I mean, a secondary school. If you went to a ghetto secondary school like I did, not ghetto per se, but a public secondary school like I did, then you are familiar with teachers beating you, right? So let's say the whole class, offends this particular teacher, and then the teacher wants to beat every single person in that classroom, right? So we are looking at a follow over them, right? Because it's going to iterate through, the entire row, and then maybe ask everybody to lie on their backs or something, based on their lockers, and then uh, beat every single person. Yeah, so that's a very good example. Yeah, and then we look at while loops, right? So while loops is a little bit different, right? Because in the case of while loop, we're trying to consider instances where you want to repeat a block of code until a certain condition becomes false. And you might wonder, why is this useful? Why would I want to run a code repeatedly? And then using a real world analogy, let's say we have maybe let's say you are what's the name? You are maybe the biggest rebel that your a particular classroom has ever had, right? And then a lecturer wants to discipline you, then or a teacher, I mean a secondary school teacher wants to discipline you, then the condition might be that you have to cry. So while you are not crying, the teacher keeps beating you. And then when you cry, then the loop can be exited. Yeah. So in this particular instance, yeah, that's a good example. Yeah. So in this particular instance, you might want to have a while loop. You want to keep repeating a particular operation, until a particular requirement or condition has been fulfilled. Yeah. So we have a value here that says that while count is less than or equals to 5, count, print count. And then while you're printing count, you're adding 1 to count. Okay, so I have to define my count, first of all. So I can have count is equals to 0, or I can say count is minus 2. Yeah, so count is minus 2. And I can keep adding to it, So it keeps working. So right here, count is minus 2. And then this condition is not fulfilled. So it prints out minus 2. Then it adds 1 to minus 2. Then it goes back to the while loop. So now count is minus 1. And then looks at the condition as well. The condition is still not satisfied. So it goes into the loop again. Add print out count, add 1 to it. It does the same when it gets to 0. The loop is still not satisfied. This condition is still not satisfied. And it keeps repeating that for 0, for 1, for 2, for 3, for 4, until it gets to 5. So from 4, while the value is 4, this condition is not satisfied. It prints out the number, then it add 1 to it, right? Yeah, so now the number is 5, right? The condition says that while count is less than or equals to, so keep note of that. So it's still equals to 5, right? So this condition is still not satisfied. It's still being satisfied, so that it entered the loop again, run the code. And then now the value is 6, but it cannot enter this loop again because this condition is no longer being satisfied, right? So that's a while loop. Okay, so moving on, we can also have a list compression, and this is the beauty of Python, right? Because Python was the first language that started this compression stuff, right? Before you need to write maybe 3-4 lines of code, to work with conditional statement and list. But now you can do something as easy as following this format. You state the condition or expression, and then you can be like for item in iterable if this particular condition is met. Okay, so we have something here. We have a number over here. Let me increase this to 10. 6, 7, and 8, and then 9, and 10. Yeah. So we want to square those numbers, right? So if we do something like this, numbers is equals to 1 to 10. Numbers is equals to 1 to 10. Then we can simply have the expression So the expression simply means that we are multiplying two star, what's the name? We are multiplying the number, we're squaring the number. Okay, so we have a number is multiplied is raised to the power of two. So we raise a number to the power of two, and then for all numbers within in numbers, so we can do something like this. Yeah, and it's just basically square those numbers, right? Yeah, and then we can do this in a different way. Let's imagine that we only want to square numbers that are even numbers, right? So we can do the same here and say squared even numbers. We want to print out the numbers, and then we could say something like this: star two for none in numbers if numbers if num. How do you know if a number is even if the number is divisible by two? So you can do something like this: 2 equals 7. Yeah. So and then we can now print square even numbers. Yeah. So and that's it. Okay. So we're only printing numbers that are we only what's the name? We only squaring numbers, that are even numbers. Okay, so moving on, we're already familiar with a string, right? So when we talk about about a string, then we know that a string is a series of letters forming words, just like sentences in a book. And then we can have what's the name? We can have pen in different forms, in different types, in as much as they are ensconced in a code. So that's what we optimize for, right? And then there are several methods we can work with strings basically. Yeah. So one way of doing this, I can have so greeting is this, and I can say greeting is hello Python members. Python members. And then we can print everything here. We can print them out. We can print out the length basically. So len is an inbuilt function that you can use to find out the length of any value. Now oh shit, okay. Oh, okay, cool. Looks like I had I'm not sure why I deleted that yet. So looks like I had this and then another value that I can't remember anyways. Okay, so yeah, you can do something like this. You can print out the length, and then we can also extract part of the text, basically list slicing. I walked us through this earlier, right? So we can do something like this where we're basically slicing a particular string. Yeah. So when you do that, what do you have? Yeah, so over here we want to slice hello. Remember that the index we start counting from 0, then 0, 1, 2, 3, 4, 5. So it's not going to print out the fifth one. It's not going to print out the stop. It's just going to stop right before the stop. Yeah, and then we can do that. And then finally about list, we can concatenate. I think I've explained this before, right? So we can do something like this, and then we can print this out. We can concatenate different strings together. Okay. Yeah, let me delete this. Yeah, so we can do something like this. Introduction. And what we have here can only concatenate string, not integer to string. So you need to be wary of that, right? You need to be careful when you're trying to convert a string you're trying to convert an integer to a string. You can only add concatenate a string to an integer, not an integer to a string. So always be wary of that. Yeah, you can only sorry about that. You can only concatenate a string to a string, and you can't concatenate an integer to a string. Yeah, you can only concatenate within the same data type, not across data types. So in this instance, we'd have to convert string age to string because it's an integer, and then we cannot concatenate successfully. Okay, so we're making progress. The next thing I want to talk about is dictionaries. So think of dictionaries as your personal phone book. I know if this is your first time you're with the programming languages, then you might assume that dictionary is like like an English dictionary, and actually it's like that, right? It's like that in a sense because you have a key, and then you have a corresponding value, right? So I mean, in a dictionary, usually you would have the word and then you have the explanation. The same also applies here, right? So think of dictionary as a personal book. You're always going to have a key, and then you're going to have a corresponding value. So look at this. We have a dictionary here. So Alice is the name. The name is the key. Always remember that we have to put it in curly brackets. And then we have the name, which is the key. Then we have the value, which is Alice. And then we have the age as well, the key. And then 25, which is the value. And then the same, yeah. And then you can now access. Remember that the way we access values in a dictionary, in a list, we have to provide the index of that particular value. It doesn't work the same with the dictionaries. You can simply provide the key, and then you get the value, right? And also you can add a new key. So the way you add to a dictionary is unique in the sense that you just need to provide a new key, right? And then you provide the value you want to add to it. So running this, yeah. So over here we're trying to print the student name by specifying the key name, and it gives us the value. The same for age, and then we have the age 25. And over here we add a new key value here, which is university and the ABC University. And then you can see the value. You can see the value out here. Okay, so that is it about what's the name? About dictionary. We are still going to work more with it, but for now let's explore that stuff. Yeah, so working with external libraries, and believe me, this is the magic of Python. Python has thousands of libraries out there. I'm not capping. Python has like thousands of libraries out there, you know, and then it's what makes Python what it is, right? It's just the way people keep creating frameworks for JavaScript. For Python, it's not that. It's libraries, every single thing you want to do with a programming language, just think it, and somebody already has defined a library for it in Python, right? It's so unique. It's so unique. Yeah, it's something I enjoy doing. It's something I enjoy using a lot. For example, I was working. Let me give you a use case. Recently, I was trying to use LangChain, which is a Python library, a framework, for interacting with large language models. I was trying to interact with a model, and then I was trying to do some sort of document search. Basically, it's like, I don't know if any one of you has used an AI assistant to read a paper before. So basically what I want to do is I want to retrieve a PDF online and then ask um, a large language model, like a ChatGPT API or something, to look through the document and then summarize it for me. Yeah. So I was having a hard time trying to fine tune my model, in the sense that I need data to fine tune it, which means I have to download like maybe 50 research papers manually, right? So that was for the, and you know what? I already started downloading papers. I had maybe about 50 or 20, about 25 papers already. Then I realized that I could have used Archive. So if you're not familiar with Archive, if this is the first time you're hearing of Archive, Archive is just what's the name? What's the word? It's a repository for researchers to publish preprints of the papers. So you're going to find most papers on Archive. And then what I was doing was like an archaic way of doing it, because there's a Python library that interacts with Archive and retrieves paper for you automatically. So me download the paper was just me stressing myself, when I could have just make use of the Python library and it's going to retrieve it for me. Then I have another library called PDF Parser, which is going to retrieve the PDF and retrieve all the documents from all the text in the PDF for me. So that was so cool, and it's sort of reaffirmed my love for Python because it's so dynamic, it's so magical, right? Yeah, and yeah, so that's it about external libraries in Python. So a good example is MathPy. Remember when the example we made use of earlier, where we wanted to work with circumference and the area of a circle, and then we had to like define our pi manually. Usually, you don't have to do that because there's a library called Math Library in Python that can, do that for you. You can just say maths.py and then you can do that. You can easily get your area of a circle. Now, one thing you need to know is that if you are importing, if you want to make use of a library, and you have to import that particular library, right? Yeah. Okay. So that's it about that's the first part about external libraries. But then there are instances where that external library does not come with default with Python. When you install your Python, then you have to install it yourself. And that's where pip comes in. You can easily install new libraries using pip. And now this leads us to another important part of what's the name of another important part of Jupyter Notebook, which is its ability to be so interactive. I can easily install the library via Jupyter Notebook. Usually, if we are using some other IDE, you'd have to open up the command prompt and then install pip, install wherever you want to install via the command prompt. But with Jupyter Notebook, you can do it right there in your notebook, and all you just have to do is to prefix it with an exclamation mark. If I run this, so pandas is already installed, so it's not installing anything more. But let's say you are doing this on your Jupyter Notebook locally and pandas is not installed, then it's going to install it for you. So that's so cool. Yeah. So over here, I'm trying to make use of an external library, which is basically pandas, right? So pandas is excellent for data manipulation and analysis. So I import pandas. Now look at this part. I could have just said import pandas, but over here I have import pandas as speedy. And this, what I did here, the speed is just providing a nickname for pandas. So every single time I want to make use of pandas, then I don't have to, I don't have to be shouting pandas every single time. I can just say PD. I could call it P, right? But the conventional way is just PD. So yeah, PD. Okay. So what I did here is that I have a dictionary called name, and then I have a dictionary called name, and then what's the name? I have a dictionary called data. Sorry, it's storing a list of names, and it's also storing a list of age. Now I want to convert it to a pandas data frame, for us to work with. And I can simply just do this. Okay, so yeah, here we have a dictionary. Okay, where we have a data frame. It's still not displaying well, so I can use display. Is it display? Yes, it's display. Okay. Yes, so you can see it right here. And it's so cool. It's so beautiful, right? Yeah, that's one of the benefit of making use of Python. It's dynamic array of libraries. It makes life easier for you, on this programming journey. Yeah. Okay. So I think the last part I want to talk about will be mathematics for Python, and then I want to say that initially some people will be like, oh, that's why we use MATLAB. It integrates better, with mathematics, and then machine learning is all about the math part of stuff, So, but you don't necessarily need to, use MATLAB because you want to do mathematics with Python. Some basic operations comes by default with Python, and then for advanced functions, you can always make use of the math module, the math library, or the NumPy library. Yeah. So so basically over here we're trying to perform basic mathematical operations like addition, subtraction, multiplication, and then division. Sorry, I'm rushing a little bit here. Yeah, so and then you can print all of them out, and then yeah, it's so basic. Yes, it's nothing, it's not a big deal. Okay, so also consider this, you know, they're trying to compute the radian of an angle, of a 45-degree angle, right? And then we can simply just like, you know, convert it to radian using math.radian, right? Oh, I didn't print that out. Print radian. It's so simple. Okay, yeah, great. And then we can do the same. We can get the cosine of a 45-degree. And this is just, it's just so straight, you know, it's just so straight, you know, elegant solution. You don't have to like stress yourself, you know, trying to compute that. Okay, so looking at other examples that I would have wanted us to, you know, work through together intuitively. Don't forget that I mentioned that Python is all about, you know, working to your problems intuitively. Always think before you start writing code, right? Yeah. So in this part, I just provided like examples of I provided examples of ways to, you know, to interact, to think about putting some of the concepts that we worked with into practice, right? Yeah. And then consider a temperature converter, right? So you have to think about it. How do we, what's the formula for converting a temperature into Celsius for Fahrenheit? How do we do it vice versa, right? So you need to consider stuff like this, and then, you know, compute your results. I mean, write your program accordingly. It's always very important that you think before you start writing. Yeah. Also look at this, the contact book. Let's say we want to create a simple contact book, you know, using dictionaries to store this contact information. How do we do this? Then you realize that, oh, I need several functions to do this. Since I need a contact book, then I should be able to, you know, to add to the contact book. I should be able to search. I should be able to delete from the contact book, right? Yeah. So now you have to define the functions. You have to define the function names. You have to define the parameters that should be needed, and then you can decide how you want to, what data types you want to use to store this information, right? Okay. So yeah, you can add, you can search, right? And then you can delete. You can check through whatever it is that, you know, you have on the list. So let's test them out. So initially your contact list is empty, and then we add contacts, right? And then we can search the contact as well, right? Which means you have to make use of conditional statement. How do you search to it? With a particular name, you have to search to the contact. So you think about it intuitively. If a particular name is not in the contact, then you have to print it out. This particular name is not in the it's not in the contact list. But but in case where the number the name is in the contact list, then you print out all the details, right? Yeah. So additional what's the name? Additional improvements on the contact list is uh, define a delete contact function. A delete contact function. So how do you delete a contact? I mean, from a dictionary, you need to think about that. You can also update a contact, update a given contact. Okay, so convert the the contact list to a pandas data frame and export to a CSV file and Excel file. Okay, yeah, so this is great. Yeah, so try to do this on your own, and then yeah, so if you're able to do it, let me know in the Discord server. Okay, so further learning. So this is more of a crash course to everything. Yeah, so if you want to, like, you know, venture into this more deeply than this, especially if you're a novice or a beginner, then you should take this Python micro course on Cargo. It's just a 7 hours course. Yeah, so So yeah, you should try those. You should try it out. Now, if you're an intermediate or you're an advanced or even a beginner, then you should try out some of these challenges in on Akaran. So you can try out the Akaran. But if that is too easy for you, then you should try out code wars, right? And then also if that is still basic for you, then you should consider the first 20 challenges in Leet code problem set. Now, if you're able to do all these three, I mean, along all the other exercises that are already in this notebook, then in fact, let's have a challenge. So if you're able to do that, then just let me know on the Discord channel, and then I what will I give you? Okay, we can exchange swag since this is not a physical meetup. And then I can promise you maybe an hour of my time, an hour mentorship every single month for the next 6 months. Yeah. So if that can be, valuable for you, yeah, then let's do that. Can't think of anything else to offer right now. Okay, so that is everything right now. And then yeah, so if there's any question, I'll be happy to take any question now.